So today we're going to talk about parent functions and transformations. And so first of all, we need to define what a family of graphs is. A family of graphs is a group of graphs that display one or more similar characteristics. That's why they call it a family. Okay, and the parent graph is the simplest of the graphs in a family. And so on this next slide, these are the four functions that we're going to focus on today. The first one is a constant function. Yes, I would hurry up and get these down. Okay, I would not sit there and not write anything down because this is something you're going to need to refer back to. And this is also in your book if you want to copy it from your book. Okay, the first is a constant function. An example is y equals 1. Even though it could be y equals 4, 5, y equals -2. The domain is all reals. Remember we talked about domain yesterday? And the range in this case is just going to be 1 because it's a horizontal line. Basically, your range is going to be whatever the equation equals. Okay? Then you have the identity function, y equals x. Domain is all reals. Range is all reals. Okay? So those are the first two, the constant function and the identity function. Next, you have your absolute value, y equals the absolute value of x. All reals is the domain, and then the range is all reals greater than or equal to 0. And then last but not least, you have a quadratic function, which is a parabola. Okay, that parabola can open up or down. Domain is all reals, and the range is all reals greater than or equal to 0. So I'll go ahead and let you get those down, and then we're going to go ahead and ask you some quick questions, and then we're going to graph some things fairly quick. Now it's important that you're able to look at those and identify. Constant function is just going to be a horizontal line. Identity function is going to be a line. Absolute value function is going to be a V. That should be the one that we all get. And the quadratic function is going to be a parabola. Okay? All right, so like I said, those are also in your book. Sarah, what page is that?
Page 109.
Page 109. So those are also in your book on page 109. So you can also get those down from, like I said, page 109. All right. So, very first, I've got a question for you with your expressions. Okay, and these should move pretty quick. So have your expressions handy. All right. So, let's see what we got here. Identify the type of function represented by the graph. Okay, identify the type of function represented by the graph. So look at that, A, B, C, or D. Shouldn't take you very long. You should be able to recognize it like that. Okay. So this is absolute value, V. Okay, it's not a quadratic because a quadratic is a curve. Okay, quadratic is a curve. Let's look at this one. Identify the type of function represented by the graph.
Didn't we just do that one?
Oh, just a second. Okay, well, we won't do that one again. Sorry. I must have hit back. Okay, let's go back because I know that this is the one that we hit and then I hit back. There we go. Identify the type of function represented by the graph. And the answer is A, it's a constant function. Okay? Identify the type of function represented by the graph. Linear, nice job. Okay. D. Okay? Alrighty, so transformation is now what we're going to be looking at. A transformation is altering a parent graph, okay, by translating the graph, rotating the graph, or dilating the graph. So translating it, rotating it, or dilating it. And so what we're going to do is we're going to talk about what a translation is, we're going to talk about what a rotation is, and we're going to talk a little bit about what a dilation is. Okay, so that's what a transformation is. Alrighty, so let's go ahead and look here. A translation is moving a figure up, down, left, or right. So if I was taking notes on this, I would write up, down, left, or right next to translation. I wouldn't necessarily write moving A. Okay, there are some times when you need to kind of condense what you see and not necessarily write down verbatim everything that's on the screen. It's also called a slide, shift, or a glide. So what I want you to do is I want you to graph this in GeoGebra. Okay, I want you to go ahead and graph y equals absolute value of x plus 2. Okay.
Why don't we have you guys go?
I'll send you 4 at a time. I'm not going to send the whole class because half of them will be written. Okay, so go ahead and graph y equals the absolute value of x plus 2. Okay, so on your GeoGebra, you've got y equals the absolute value of x, and then you're going to go ahead and add 2. ABS.
Oh.
Really? Okay, so remember once again how you would enter this into GeoGebra is you would go ahead and do, oops, there we go, I guess it was already on there.
Do I just leave it alone?
Apparently, whoever holds it from 4 hours is up.
Why?
Because they're all saying
So if you go ahead and graph that in GeoGebra, you're going to get something that looks like this in green. So I want you to compare this with the original absolute value graph. What has happened here? What has it done? It's went up 2. So this is what you would write. Okay, you would write shift up 2. Okay? Describe the translation. Shift up 2 is what you would write.
Do you have to use shift or you can say
Moved up 2. Okay, describe the translation in y equals x squared minus 4. So how you're going to enter this in, guys, is you've got y equals x caret 2. The caret is located in the by the number 6. Okay, you see the caret? It's right above the number 6. Okay, it's right above the number 6 is where you're located. So after you type that in, what does it look like you've done from your original graph when we had that original one? You've moved it what? Down 4. So what has this one done? This has went down 4.
You don't put this in parentheses.
No, I said I have it written up there what you type in. X caret 2 minus 4.
Wait, I don't understand why it says it's down 4.
Because
your equation?
yeah, it's moved down 4. Okay, now if you're wondering what do you look at for the original graph, you wrote all 4 of those down in your notes. That's what you're looking at. And if you look in your notes, the x squared is something that looks like this. The x squared minus 4 that you graphed looks like this. Okay, so it's went down 4. Okay, now this one, a reflection. Basically, reflection is like a mirror. It flips a figure. Okay, and it flips a figure over the line called the line of reflection. So what I would do if I was making notes, and I was taking notes here, for reflection I would say flips a figure. Okay, you don't necessarily need everything else that's with that. So it says describe the reflection in y equals negative x squared. So in GeoGebra, I want you to graph y equals negative x squared. So the question is, how do you write that in? Negative x caret 2. So that's how you type it in. So compare that to the original one you wrote down. What happened? What did it do? It flipped down. So what would you say? You would write, it flipped. Okay? Flipped. Make sense? Not that bad? Okay. So a dilation shrinks or enlarges a figure proportionally. So I want you to type in 4x. Now that's how you write it in. Y equals 4x. Okay, so y equals 4x. Okay. Why don't you What do you notice about y equals 4x? What can you tell me about y equals 4x?
It's an identity.
Yep, it's an identity function. And if you compare it to the y equals x, look at what it did. Yeah, it made it steeper if you think about it. Okay, because look at that green function. What did it do? It now shoots up a lot faster. Okay? So describe the dilation in y equals 2x squared. So let's type this into GeoGebra. So I get y equals 2x caret 2. That's what you're going to type in. What happens to it? Yeah, it's a quadratic function. What does it do? It narrows. Perfect. That was exactly the word I was thinking of. If you notice, it narrows. Your y equals x squared, if you graph that, is going to look something like this. The one that you just got done doing is going to look something like this. Now come quiz time or test time, if you're worried about what you write and you don't know necessarily what to say, a good rule of thumb, always write your graphs down. Okay? And then that way, you know, like you could do this, narrows. And you could draw an arrow to this. And then that would tell me, okay, they understand that it changed from the original graph. All right, so here you go. Pages 113 through 114, 10 through 31. Now those of you that are going to be gone tomorrow, okay, you're going to need to find a time. You're going to need to find a time to get this done. And those of you that are going to be here, if you want to, I'll have the netbooks here and you can work on it tomorrow. Okay? So that is the plan.